Storm Adam to his mum is a Kiwi hacker, the breaking into things sort. White hat security consultant from New Zealand InfoSec thought leaders Insomnia Security, and believes that every year since 1999 was the year of Linux on the desktop. They'll have to go talk to B-Dale about that one. Metal runs KiwiCon, the New Zealand HackerCon, and is a pundit on multi-award-winning weekly InfoSec news podcast, Risky Business. Beyond this, Adam's primary qualification to speak at LCA is his #1 hit for a Google image search for Unix beard, which is pretty impressive, and has been since 2008. He's also insanely popular, it seems. Over to Adam.
I have to confess, I was #1 hit for Unix beard for several years, thanks to a photo with me and Andrew McMillan at LCA in 2008, maybe. I've now been displaced down to about #5. And I think it depends where in the world you are in your search, but at one point that was true, even though now it's a blatant lie. So ladies and gentlemen, Mr. Dennis Ritchie, fuck yeah. You'll excuse my wonderful GIMP skills. I didn't use Photoshop, you'll be very pleased to know. It is actually GIMP. Anyway, yes, so I am Adam, otherwise known as Metalstorm. My business card says that I'm a Unix berserker, but actually I'm just kind of a jerk on the internet and I get paid for it, which is a pretty sweet career. And as previously mentioned, I am organizer of KiwiCon, the local New Zealand HackerCon. We take ourselves very, very seriously. It's an extremely serious event, unlike this one. And I'm also engaging in a new career path as a media pundit, which basically means that I talk bollocks on the internet, which is much like my regular day job. So this talk really was inspired by the book called The Art of Unix Programming by ESR, Eric Raymond. And this book attempts to codify what makes a Unix Unixy. It's not just about beards and sandals and socks. Much as you might think that was the case given this constituency. But no, it codifies these principles that make a Unix like a Unix. And one of them is called the principle of least surprise. And if you've ever seen the emoticon that goes, then that's pretty much what this is about. Anytime you see something surprising, it's not very Unixy. And so I thought it would be good to do a talk that describes surprising Unix things, and indeed, not just any old things, party tricks, because generally anything that's surprising is probably going to be fun. So we're going to go through a few of those today. There's going to be things that people almost certainly know about, and certainly in this audience I would expect you to know about them. Some things you really should know about, especially if you're a sysadmin, because you don't want to get your boxes wildly owned. And then we'll have a bit of light party trickery, a few things that I've written, other people have written that are entertaining. And then maybe a couple of, like a brief token hint of things you could do to be less surprised by your boxes. And then you can flame me, and that'll be fun. So, what's a party trick? And what do I think of as a party trick for the purposes of this talk? Really, it's Unix things you didn't expect, and generally local Unix things. So, not network, remote things, because those are generally called exploits. But so local things that are not what you expect. And generally these are places where, for example, the POSIX standard itself is crack-headed, and we might talk about one of those. There's some places where things combine in counterintuitive ways to produce a behavior that you didn't really expect. There's places where Unix is just too powerful for its own good. And all of these really are features. They're not bugs, they're not things that are going to be fixed. In some cases, they are things that have been fixed because they're just not sensible. But really, these are the way things work. And sometimes that's entertaining. So for example, a good example of what a party trick is. The execute bit on your file system permissions, that's just for fun. Right? It doesn't actually do anything. That's recreational execute permission. So if you go around and you set your binary that you don't want somebody to execute, that not execute, you take away everybody's execute permissions and you think, yeah, no jerk's going to execute that now, huh? That's not actually true. Like, not even slightly. I mean, the obvious example is I can just copy the binary somewhere else and set the damn execute bit. But okay, well, let's leave that one aside for a second. Somewhere I have a shell. I have a billion shells here for you. Where did I stash this particular shell? Right. All right, so here, is that readable? Roughly. So I have a binary here called hi there. Slightly to the right. Right. Anyway, so I have a program called Hi There, which pretty much says hi there, as you'd expect. I compiled it and I can run it, much as you'd expect. And you'll notice that, if I take off my caps lock because I'm not shouting, oh wow, it actually recommends SL. That's hilarious. Have you guys ever run SL? Yeah. That's, yeah, Go Ubuntu recommending helpful things like that. Like all the users are going to love that. For those of you who don't know, it's for when you mistype ls and it makes a steam locomotive go across your screen in ASCII art. It's very funny. Anyway, so I have a copy of the binary. I've also copied it and I've taken away my execute bit. It's called hi there no. And if I try and run it, it's like but no. Right, I'm just going to run LDD for reasons that will become immediately apparent. Yeah, that's a recreational execute bit. Now, everybody knows that, presumably. But somehow it's still surprising to sysadmins when they take away the exec bit. And if you've got read, you can run it. You just ask the loader to run it for you. Because what's the loader's job? Well, I'm going to read an ELF binary off disk. I'm going to load it into memory. I'm going to resolve some symbols, and I'm going to exec that. So that's the loader. ldlinux.so, and here's the ELF binary on disk. Hey, look, I read it. So recreational execute bit. That's an example of a Unix party trick, in my opinion. If anyone disagrees, feel free to leave. Because the rest of the talk is filled with this kind of silliness. Obviously, if you have, say, a file system that's mounted no exec, then this trick doesn't work, but there's a few other ones that do. So generally, stopping people executing binaries on your box with file system permissions, not going to work, unless you take read away from them, presumably. Assuming that actually works, which I guess it generally does. So as we're on the subject of file system permissions, let's talk about file system permissions. Now, my job, amongst other things, involves busting into very fancy, expensive Unix boxes that are run by sophisticated Unix admins that do very important critical infrastructure type things. And you would expect that most people who run critical Unix infrastructure, cough power, cough planes, cough telcos, would know a few of the basic things about Unix file system perm. So let's have a look at this one. I have my demo notes on my, to the right. Oh yeah. Is it good? Perms, right. So I'm on a box, unsurprisingly, it being a Unix talk. All right, and now I'm root on the box. Now, if we have a look at cron tab on SL, we will see that, amongst other things, root has a couple of cron tabs, and one of them is this data weasel thing, which I'm guessing is weaseling some data, which is pretty enterprise, pretty critical infrastructure. And if we go and have a look at pin data weasel v10, because it's a new version, right, there is a script that's going to be run by root's cron job to collect some data about a weasel or whatever. And as you'll see, the permissions on this file are correct. As a non-root user, I am not going to be able to escalate privilege via this binary, except for a problem. That directory is world writable. Now, what that means is what do you think is going to happen when I go ahead and stick my shell script in there? Well, what happens is it gets run by root and I escalate privilege and I win on the box. Now, most people, you would think, understand that file system permissions are not just on the file or the directory that they're in, it's the entire path by which you get there that matters, because you have to traverse all the way through to get there. A path is actually a set of qualified components that are multiple directories, etc. So if you install Oracle, for example, on your critical infrastructure system, and you leave one of the directories world writable, which by nearly every Oracle box I've ever seen has one of them, somewhere, everything below that in the path, I'm going to come along and hacks you with. So when you're checking file system permissions, it pays to check the entire tree, not just all the tree. You have to read all of the words, not just some of the words. You'd think people would know that, right? How about temp races? Who knows how to exploit a temp race? Predictable file name in temp that's going to get you root. Do you want to see how to do it? If you haven't already? Yeah? All right. This is probably my most demo-heavy talk I've done in a very long time, so hopefully it doesn't go horribly wrong. I've made the appropriate sacrifices to the demo gods. All right, let's have a look. Doop-a-doop-a-doop. All right, so I have temp fail. Right, so here we have a binary, which is a very, very red Seward root binary. That sounds like a fun thing to play with. Let's see what it does. Because like randomly running every Seward binary you see is a great idea. Let's see what it does. Okay, so it's obviously an enterprise system that does some weasel monitoring or whatever. So I better check the temperature of the weasel. Presumably the weasel is USB connected, which is why it needs root. We're going to talk libUSB, blah, blah, blah. So it's some kind of USB weasel. Right, and currently the weasel is 33 degrees centigrade. So it's not too hot, not too cold, kind of just right for a weasel, I guess. Now, the question is, how does this thing work? Like, I'm on this box, I'd like to escalate some privilege. Well, let's have a look. What does it do? Let's strace it and see. strace, if you haven't used it before, is a system call tracer attached to the debugger to the program. Will show you all of the system calls it's making into the kernel, which gives you a reasonable idea of what the program is doing. You don't get to see the internal logic of the program, but you can see how it's interacting with the rest of your system. And here we can see, for example, our friend WeaselTemp, WeaselTemp is going to open a temporary file in /temp. And the name of that file is WeaselTemp with a number. Now, if we nip back up here, we might notice that oh yeah, look at that. Yeah, good spot, and I'm glad to see you're paying attention. Anyway, we can see that that number conveniently is its process ID. So if we can figure out what the process ID of the WeaselTemp is going to be, we might be able to make something in temp in advance, and that might let us do something. So I can predict the name of a file in temp. I can make a file in temp because temp is world writable with some sticky bits, and let's see what we can do with that.
I'm just surprised strace worked on the set UID binary.
Yes, so when you strace a set UID binary, it doesn't run set UID. Now in this particular case, because it's a demo example, the program executed correctly. If I wanted to do this with a real binary that I couldn't run under strace, I'd have to copy it off and run it in a test environment and do this kind of instrumentation there. But for the purposes of this demo, running it without root is sufficient because really it's just sleep 20, make up a number, print it out, you know, just between you and me. Anyway, so if I make a file there, I might be able to win. Now, fortunately for us, it takes a little while to run. How convenient. So I don't have to race it too hard. I could, of course, make a whole bunch, so I can figure out what the next process ID is probably going to be. You're not running the process ID randomization patch from DS Security. So I can probably guess the process ID. But anyway, point is, I can race it. So what I'm going to do is, I'm going to grab another shell on that box. I think I might make a symlink to somewhere in, I don't know, cron.d, might be handy. And I'm going to symlink that to WeaselTemp, and I'm going to run pid of WeaselTemp. Right, that looks about right, eh? So if our friend WeaselTemp is running Seward, like that, and I did that, right, you'll see there is a symlink called WeaselTemp, something like that, pointing off to accept your cron point. All right, let's go have a look now that it's finished running. How convenient. There is a file created in cron.d where cron, of course, is going to read it and use that to execute commands of my choice, which, oh, hang on a sec, it's owned by root and GID KiwiCon, which is me, but I don't have group write. Well, that's unfortunate. I didn't get anywhere, did I? Well, fortunately, if we look through this strace output, we would notice that it's not actually making a umask syscall to set the default file system permissions. So, how convenient. Let's try this again, shall we? Umask. Right. Start up the Weasel guy. Oops. Click on the other shell. Make me a symlink. So there's the old one. Any second now, 27-degree Weasel says, it's still there. Yeah, I'll make a point somewhere else for now. Go, Mr. Weasel. How hot do you think it's going to be this time? Get a number? Hey, who's going to be closest? You'll win a prize. 31. 31-degree Weasel. All right, let's see. Loser. The loser is you. Etc. cron.d Oh, look at that. Group writable, how cute. Right, so now, of course, I can go stick a command in there, which will be run by cron as root. I've escalated privilege through a race condition with a predictable name in temp using a symlink. Classic Unix party trick. Hopefully all Unix sysadmins know how that works, because every piece of commercial Unix software ever makes predictable files in temp. Sorry?
It's enterprising.
It is, it's very enterprising, which is something I look for in a piece of Unix software, because it means I can own it in 5 minutes and go to the pub. Now, of course, earlier on you saw me using LDD to extract a list of dependencies of a binary, lists of the shared objects, the DLLs if you come from Windows, that people use in a particular binary. The funny thing about LDD is it's actually a shell script that just runs it. So you're on your university Unix box, not that I'm encouraging you to hack a university, seeing as we're in a fine university facility. If you're on a university Unix box and you want to own it, compile some random binary in your home directory that does not have a met dependency, ask the sysadmin to make it work, because I need, like libgcc blah-de-blah-de-blah, or some crazy, Erlang runtime, or whatever the hell else you're doing. I guess Java, if you're in university, that's probably what it is, which not so much with the LDD. But anyway, so LDD is just a shell script that runs stuff. So you ask a sysadmin to, fix the dependencies of your binary. He runs LDD on it, and it executes as root, or at least it did for 1997 to about 2012. It got patched in the Red Hat LDD, or upstream, I think, about mid-2012, so it now doesn't actually do this. But for the longest time, LDD on an unsafe binary was a sure way to get yourself owned, which I thought was an amusing party trick for a long time. How many of you guys run X11? How many run Wayland? Oh. How many just like bit bang that console frame buffer? Hardcore, man, hardcore. Anyway, X is pretty awesome. X has been around for a very long time, and it's a very powerful network-aware windowing system, which of course you know this. Unfortunately, there are a few risks with X that people sometimes don't think about. In commercial Unix environments, it's quite common for people to run crappy Windows on their desktop and then have to SSH off to Unix boxes. And if you buy anything from Sun, now Oracle, it's probably got some stupid Sun, now Oracle graphical thing you have to use, like a pointy-clicky like install wizard for your oracles or whatever. Anyway, the traditional way that you dealt with this was that you SSH'd and X forwarded. Well, the traditional way was you just opened your X up wide open and pretended it was all fine. But in the more modern world, you SSH'd with X forwarding to your web server or your system that had a graphical X application you'd like to use, and you exported it to display back to your desktop through the secure SSH tunnel, which is very good. No more crazy magic cookies being stolen on the network or whatever else. This is actually surprisingly dangerous. And people don't always realize this. So let's have a look. So here I have a box that's graphical, nice Ubuntu VM, running X, nice and graphical, whatever. Let's pretend that it's got some enterprise GUI app on it, and I'm going to SSH from my crappy Windows desktop, running some kind of crappy commercial X server, or X Nest or whatever, on my other box, and I'm going to log in with X forwarding. Going about my business, right? And you can see that I can run Xterm from the Ubuntu Quantal box, and the display has been pulled back to my real desktop. So I can go about my business. Let's say, because I'm enterprise, I'm going to run like XIs or something, right? That's totes enterprise business. So I'm going about my job as a enterprise DBA running XIs, and let's say that this box gets owned, right? Let's say it's an Oracle box and it got wildly owned, because that's what happens to Oracle boxes. And you might think, because I'm running X through SSH, it's like really secure and stuff. Unfortunately, what that means is you created a tunnel through your SSH to the now compromised box, connecting your X display to it, which means I, as an attacker, now can talk to your X display, and that might be a bad thing for a number of reasons. The first being, perhaps, let me think, it's going to be on localhost display 10 probably is where it is. I'm over here, I'm typing, let me think one. So I'm using my XKCD password generator, right? I should make 3 unrelated words, remember the mnemonic, typing them in. Unfortunately, I'm now sniffing the keystrokes on this X display, which is a bad thing. And of course I can do this because there's no concept of security inside an X display. If I can talk to the display via whatever mechanism, then generally I can do whatever I like. Another thing I could do, for example, might be, let's have a look. X WinInfo minus tree minus root display. All right, that's going to list all the windows that are currently on my real X display. Let's see if we can find the one that has this in it. So let's go look for window title is going to be Vim. Right, there's a window. So let's go display. No, 1 display 10. Now we want ID of OX4C. Pipe it through because we're nice in Unix. Did I get the ID wrong? Oh, actually, it's the other ID, isn't it? 3A 4C 61C. Yeah. And there, of course, is, this is obscured because it's behind this window. But anyway, you can see that I have a screenshot of this window that I've stolen across the X11 protocol from this compromised box. So being able to see your keystrokes, steal copies of your windows or your entire desktop, right? That's going to be useful. Another thing I can do is I can just send my mouse and keyboard over onto your desktop and type into your terminals. There's a command called X2X, which lets you join 2 X displays together for the purposes of sharing input devices. Yeah, I can just do that across the SSH tunnel that you set up for me, and assuming that you're not there, maybe you don't notice your mouse going do 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 do. Oh look, a root shell. Do 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 do. You can also do it generating synthetic input via the Xtest infrastructure, so you can actually enter keystrokes or do whatever you want without having to actually physically mouse around. But it is very funny when you're sitting at home, owning somebody's corporate environment, and you get to the point where you can just mouse off the side of your desktop and onto the corporate network, and mouse back again. It's very convenient, very powerful. Thank you, X11. Moral of the story being, don't export off your primary display into untrusted places. If you absolutely have to do it, run up an XNest and forward that around. These days, a lot of people who are running Oracle boxes or whatever that need graphical stuff run XVNC so that the X display is actually on the remote server and you connect to it via VNC because that will go hopefully better for you than forwarding X11 around. And I guess with the death of Sun, people don't run Unix on the desktop anymore, so I was expecting a noise. Right, let's carry on. So say you turn up on somebody's Unix desktop via X11 trick like this. What are you going to do? Well, obviously I can sniff keystrokes already, and I can execute commands. But okay, we're talking about party tricks. What other party tricks can you do? There's this thing called dbus, which roughly replaced like the crazy Bonobo Corba or the KDE DCOP or whatever else. It's a component interconnection bus thing so that all your desktop apps can talk to all your other desktop apps about absolutely everything all the time. So for example, let's say you're using the default Ubuntu chat utility to talk to your buddy. Like this is my mate Osama bin Somnia. And I'm talking to him, and look, up here we can see me running a dbus sniffer, and like there's the clear text comms. If you're running OTR for crypto chat, the crypto occurs in the back-end process, which is not really the front-end process, and how are they talking over dbus in the clear? So your encrypted chats about cyber war with your robes and wizard hats or whatever, right there for everybody to see. Unfortunately, it gets worse, and I didn't know about this one until I started putting together the material for this talk. Go Google Zeitgeist. This is the crazy Ubuntu thing that logs everything you've ever done all the time into a SQLite database in your home directory. And I can talk to this over dbus and ask it questions like, what did Steve do last week? What documents did he have? What links did he click on? What nasty things did he look at on the internet? And I can query this across dbus, which I think is hilarious. Of course, I could just steal the SQLite database, but then I have to parse the stupid format, the table structure of that SQLite database, which is not pretty. But really, if you're wondering why your modern Ubuntu desktop is grinding the whole time, like and smacking disk and running like copies of cat that you don't know what it's catting, it's Zeitgeist, like indexing everything you've ever done. There's even a GUI that you can bring up. You can like browse back in time and see everything you've ever done, which I think is creepy. Not to mention a waste of my SSD's write cycles. But yeah, you might want to turn that off, or at the very least, looking at to see what you did last week when you're filling in your timesheets or faking them or whatever. Looking at you. Yeah. So yes, it's pretty crazy. All right, let's talk about rootkits. Who likes rootkits? I guess you're all, hey, look at that. I thought you'd all just having running the fucking leeches. We did famously, like hackers famously got called leeches on the kernel mailing list by Linus, which I was quite proud of that, I guess, a leech, I don't know. Anyway, so how about a rootkit that doesn't need root? Do you think it's possible to hide files from root when you're not root? Because often, like, I own a Unix box, and it's like some ancient Sol Spark thing, and it's really, really important. And if I've got a kernel Prevesc on Solaris, it might not be super reliable. And this is like a GSM core network box. It might not be very good to just like / something I got off Packet Storm in 1994 on one of these things. So often getting root is difficult and risky when you're an attacker because you might get noticed, you might screw up, you might crash the box. So being able to do things as not root sometimes is a useful thing. So let's give this a try. If I find the right desktop where I stashed this. Not that one. Aha, this one. Right. So here I am on my local box. As you can see, I'm right terminal to the right. This one too. Right. Here I am, wandering around my box that I've owned. I'm not a root user. Ignore the fact that I'm actually in the admin group, this being my local desktop. And I have picked a place where I'm going to hide my files that's hopefully not really going to attract a bunch of attention. Like, who's going to look in .local share totem stash? Right? Maybe stash might give it away, but I mean, who worries about what temp files totem's writing around, unless it's filled with pirated mediawares, which actually hilariously this was until I went to clean it up before my demo. Sorry, Linux filled with Linux ISOs that were legally acquired in the. I bought them from Antigua. It's fine. Anyway, so in here I have stashed a file that I don't want to see people to see. It's called Secret Hacks, and it has some really secret things in it, right? And I want to hide this from root because root's going to come along and look around. Maybe it's a backup process. Maybe it's a file integrity IDS like Tripwire, AID or whatever you open source hippies run. Oh yeah, I said that out loud. Sorry, inner voice. Right. Anyway, so I have a file here that I want to stash and hide it from root. So let's give this a try, shall we? Local share totem stash secret hacks. Right. Now let's say root's come along. Maybe he wants to back up my home directory. It would be bad to have my secret stuff backed up by root because then he might notice it later on when he's doing forensic incident response. I definitely don't want to be caught by forensic incident response. Let's have a look. So I'm going to tar up my .local directory, let's say, as root. And then for the purposes of the demonstration, I'm going to immediately untar it. And then let's grep for this file that we know is going to be in there because I got this in the table, right? Secret. It's not in there. Secret hacks.txt, that's what it was called, right? See, the file's secrethax.txt, right? It's not there. But, oh, where'd it go? It's not there. How miraculous. Oh, there it is. So you've seen those guys who do the shell game trick where you put a thing under one thing under 3 shells and you like that? That's what I'm doing. All right, I've got a kernel iNotify watch on the directory is heading towards where my stuff's hidden. And when I see someone traversing through the directory, I unlink it off disk. Wait till they've gone past, put it back down again. So that's the lossy version. Like if the system gets shut down during that exact point, obviously I'm going to lose my data. I have another version of this which unlinks it in one place, so it links it down in another place, and then waits for it to go past the first place, unlinks it off here, puts it back there. Right, and this works. And okay, what's the command that lets me enumerate iNotify watches on the system? Right? there isn't one, as far as I can tell. Go grub around and proc somewhere, and maybe it'll tell you. Surely, is there an iNotify developer in his house? No, didn't think so. So yeah, that's how you hide files from root as a non-root user. And that's just the party trick, right? It's exactly the behavior that iNotify is designed to provide, right? I'm interested in someone looking around the directory tree near me. And then, right. How about processes? I would like to hide a process from root without having root, right? Because that's another core feature of a rootkit. I want to hide files, I want to hide processes, and maybe I want to hide network connections, which is a little more difficult. But let's go with hiding processes. Well, there's a few ways that you can do this. Right, let's go with the first one, level 1. Level 1 hiding. Find me a shell. Okay, so here I am on my box. All right, that's what I get for pre-laying out all my shells nicely sized for you guys in advance. I spent like 20 minutes on it now, I have to move it. Anyway, right, so here's me on my box. And as you can see, some time ago, I started a top process, which is running up here, keeping an eye on my business. Now, if I start a process called, like SciBounce on your box, which is an ISE bouncing proxy that script kiddies use, if I start a process with an obviously script kiddie name, sysadmin's probably going to notice. If I start a process called ./Java and then like 400 pages of environment variables, and command line arguments and class paths and all sorts of crazy Java -X and blah 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 blah, right? You probably won't notice, but okay, let's say that the sysadmin is pretty good. And one of the things that a sysadmin might look for when trying to spot a rogue process is, when did it start? Right, because a process that starts up at roughly the same time as the rest of a bunch of other similar processes is probably related. If I have a Java process which is started 3 weeks after every other Java process on the box, it might be worth looking at. So the question is, can I start a new process but keep the process start time of an old process so that it doesn't look out of place? Let's give it a try. Actually, I was going to use top, wasn't I? No. Right, so top has gone away and been replaced by me editing temp hacks. Still there. Still running at the same start time. Still called top. But it's me running VI on temp hacks. Now, just to show you this is true, let's go and have a look at the open file descriptors there. So if we look at ls-la proc 27181 FD, you'll see, indeed, right, it is a process that has currently got an open file handle to temp hack swap, right? So clearly that is the VI process, and it really is editing temp hacks, but it's called top, and it has the start time of the original top. Right, no admin's going to spot that one. Of course, he might notice that his top went away. And of course, because I'm doing this in a foreground window, you can see obviously that it changed. But say I did this to a Java worker thread, right? I have a big worker pool, right? He's not going to notice one missing Java worker, right? But okay, maybe that's not as sneaky as it could be, although I think it's pretty sneaky. Maybe there's a better way that is more sneaky. Actually, if you're interested, that's I'm using ptrace to attach a debugger to the running process, and then just using the exec syscall to replace the process image in the same process. So exec without a fork, which results in inheriting the process start time of the earlier process without, and doesn't change the PID, etc., etc., which is entirely intended behavior, and not at all surprising to anybody, hopefully. Okay, but let's say I made that process go away, and that was potentially something that's going to get me caught. Let's see if we can find a sneakier way to do this as non-root. So let's go level 2. Level 2. All right. I have another shell somewhere around here. Here we go. All right, so here I am on another box. This one's 32-bit because this piece of code I haven't ported to 64-bit yet. So I'm on a VM that's 32-bit, and over here I have a top process running. Let's have a look at it, shall we? All right, so you can see I'm running top minus D5 U KiwiCon, so a delay of 5 seconds, only show me processes owned by a particular user. All right, and you can see the start time is from a while ago, like 132. All right. And as you can see, top is is actually running. I'm just pressing space to update it so you can see. Right, is indeed a real live top process. Right. Right, so I did a thing to it, which involved some ptrace and some voodoo and some things you really don't want to know about. And as you'll see, like Top's still going about its business. Hang on a second. Now, I know Top's pretty awesome, but I didn't realize it was network enabled, right? You know, it's Cloud Top. Hey, look at that. We have a shell inside Top. And hang on a second, is Top running? Now, I heard someone yesterday dissing on the pthreads interface. Yeah, that's what I say to you, buddy. Got a pthread right up in there, in your top. Anyway, so yeah, this is a process or a tool that will attach to a running process, inject a new thread into it, and then shovel a payload into that thread and run it. In this case, the payload is essentially shell code. It's position independent machine code. That was actually, the payload that I injected is actually compiled from C. There's a compiler written by some crazy Argentinian guy that takes C as an input and it's a GCC backend that generates position-independent shellcode output. So you can write arbitrarily complex C programs and inject them. Has its own like libc and everything. It's pretty cool, apart from being entirely insane. But anyway, so I injected that into the process, and of course now I have my network listening persistent backdoor hidden inside somebody else's process. Which I thought was relatively entertaining. Right, let's carry on. Oh yeah, so there is a level 3 version of this, but I'm still using it in the wild, so I'm not going to tell you. Haha. That's what the otter says to you. Of course, yes. Yeah. Well, when you start a thread, you can say to the process, like, do I terminate when the main thread goes away, or do I terminate when all the threads go away? And actually, that's set to terminate when all the threads go away. So Top will appear to stop and just not return to a shell, but actually will keep running until my other thread gives up, which it doesn't give up. Well, not so easily anyway. Sometimes it segvies horribly, but other than that. All right, let's talk about another party trick quickly as I'm running out of time, although I guess anyone who wants to go and have lunch instead of see party tricks is welcome to piss off. So there's a tool I wrote in 2003 called SSH Jack, and this is an interesting toy. Say I own your desktop via a browser bug or a libpurple bug, because God knows that would never happen. Own your instant messaging client. Seriously, don't run a libpurple-based messaging client. You're asking to get owned. Just don't. Just use like the Google Gtalk in-browser chat client. Anything else is going to get you owned. Anyway, so say you get your desktop owned and you're SSHing off to your, let's say the name service for New Zealand because you're a sysadmin and you look after them. It would be really cool when I own your box to just kind of hop across your SSH session that's already there and pop out the other end without having to steal your keys or your passwords or whatever. Anyway, so I wrote a tool that does this. Now, if you're familiar with the SSH protocol, essentially SSH client and server talk a network protocol, which is a multiplexed encrypted channel transport thing. So there's a big pipe which is encrypted, and across that you run multiple things. So that's how you can have port forwarding and a shell across the same SSH connection. Now, it used to be that, this is an inherent property of the protocol. Back in 2003, there was no SSH master mode. There was no way to use this feature. So I wrote a tool that dynamically attaches a debugger to your running SSH process, turns on the master mode features, even though at the time there wasn't any way to do that, and then sets up a connection across the top using the existing authenticated tunnel. So essentially, you can look at a client, pop out the other end, no interaction. Would you like to see it, or would you like to go and have lunch? Right, let's see if I can find the right window. Right, this will do, I think. Actually, no, a different box. Actually, no, did I want that box? To remember where I stashed this. Yeah, that'll do. All right. Right, so I have two shells on this box. I'm going to, as the same user that I'm running as, SSH as root to, for the purpose of demonstration, localhost. Right, I'm going to type in my secret password, which is not that. It's a different password, which is the following. Anyway, so now I'm logged in as root via SSH. Now, Dirty Hacker comes along, spots that, oh look, I am currently UAD KiwiCon, and that person is SSH'd off as root somewhere else. Wouldn't it be nice if I could have root on that box? SSH Jack. It's going to do some, once again, extremely disturbing things. And now it says, hey, I totally jacked you a session. I run that, and wham, I root out the other end. Now, that particular SSH connection was configured with no master mode, was not turned on, although this is SSH version 4, which does support it, completely turned off, and I've just popped out the other end. And of course, I can equally SCP across it, I can port forward across it, I can do whatever I like. I can do that to a running SCP that I see running around in your system. So I log in, I spot your SCP-based backup or your rsync over SSH, nip down that just as well. And that's a lot of fun for very rapid transitioning through Unix admin networks. When you find one, off you go. And that is why you never SSH from your less trusted DMZ box to somewhere else, because all the dirty hackers in your bad PHP web server will follow you. So don't do that. So that's SSH Jack. Now, there are a few people who ruin parties, and one of them is Keys Cook. I don't know if you know this guy. He used to work for Canonical for a number of years. I believe now has rage quit and gone to Google. And he did a number of things that make Ubuntu actually empirically better than all of the other distros from a security perspective. And the biggest one of these is he introduced a kernel patch which restricts the ability of a regular user to attach debuggers to things. There's a kernel sysctl which says you are only allowed to attach a debugger to a process which is an immediate descendant of the debugger. So like strace on a binary will work, the binary is a descendant of strace, but I can't just go around randomly attaching my nasty Python debugger to go running SSH client, and that's a good thing. If you want to see quite how depressing the state of Linux kernel security is sometimes, go read the thread where he proposes that patch upstream and gets brutally smacked down by everybody, which is why this is not in anyone else's distributions. They say, you should use SE Linux, and I'm sure Russell's in the room and we're about to talk about that. On the other hand, whilst I like Ubuntu for some reasons, ptrace scope restriction is one of them. Another one is they run the Coverity source code checker across everything in Launchpad and then file bugs about horrible vulnerabilities in it, which is also nice. But then they also introduced, like Unity and Upstart, and they made all my VMs run like shit because of software GL rendering, and then app ports constantly whinging about, oh my god, something blew up, should I send the core dump off to Canonical? Shut up already. So yeah, Ubuntu, sadly, is actually a good choice from a security perspective, despite everything else, even if only for that one reason of the ptrace restrictions. But really, overall, the crazier our Unixes get, the better the party's going to be. Like the moment we cram it onto tablets with pointy-clicky touch interfaces or dbuses or whatever the hell else we're doing to it, it makes all this complexity, introduces A, bugs, and B, weird corner cases of things people didn't think about. And those generally are where the parties happen. And you may say, well, fortunately, SE Linux is going to take care of this. Unfortunately, the default SE Linux policy on Red Hat is 135K lines of code. Like, that's the policy file. It's not SE Linux, that's the policy that describes what you're allowed to do on your box. AppHammer policy, this big SE Linux policy. Which is why I'm not particularly confident that anyone's going to run SE Linux effectively. Anyway, I'm running to the end. I think if you like this sort of thing, you should come to KiwiCon. It's going to be 9th and 10th of November this year in Wellington, New Zealand, and we have it in an opera house. I see your university and I raise you opera house. And it's very serious business. This is our official KiwiCon beer from last year, the Persistent Bitter Threat. We may have already seen the KiwiCon Cyber War beer, which is important to drink every time someone says Cyber War. And we have awesome high roller tickets where you can pay $50 for a regular ticket, $60, or you can pay as much as you want. And if you're one of the highest rollers, you get awesome handmade high roller badges. In this case, 1960s IBM 8-track backup tapes with hand-embroidered badges and things, and cat blankets, lovingly screen printed by Shower over there. As you can see, very, very serious business. And we have sophisticated accountancy systems. I would not like you to think that we are just willy-nilly throwing your money around, although in actual fact we are willy-nilly throwing your money around. Right, so I'm done. If you have questions, I imagine that we're out of time, so tough. But I will be lurking about the rest of the con, so feel free to come and flame me, or tell me your party tricks, or any other opinions you might have, such as, is it too soon to Photoshop Dennis Ritchie into a party hat? I don't know.
Thank you very, very much. You've given us a lot of stuff to consider. And